My name is Pranav Devalapalli, and this is my Physics 2212 Lab 4 report. So the purpose of this lab was to determine the behavior of various circuits with resistors, behavior including things like current, voltage, and other things, and to look into resistors and capacitors and Ohm's law. Fundamental concepts and models utilized in this lab were Kirchhoff's circuit laws, like the node rule and the loop rule, Ohm's law, V equals IR, and the concepts of potential difference and voltage. As you can see on the right side, we have Ohm's law towards the top and Kirchhoff's rules as well. So the method of this lab was to utilize the PHYS lab simulator to create various circuits and use an ammeter and a voltmeter built into the PHYS simulation software, measure necessary values like current and voltage and other things, and record and analyze the data. And a quick preview of the results were that the experimental value for RC was calculated to be 6 seconds. Within the experiment, the system was the circuit and its components, and the surroundings is everything else. And some assumptions and initial conditions that needed to be made were that the wires had no resistance, the ammeter and voltmeter had negligible resistance, and both of these assumptions and initial conditions were made to keep it ideal and simple. So the first part, or part 2 of the lab, was charge conservation and energy conservation in series circuits. And in the circuit shown on the left, which was what we had to do, the ammeter readings show a current of 0.02. And when one of the ammeters was flipped, the readings did not change. It did not become negative or anything like that. When one of the ammeters was replaced with a voltmeter, the voltmeter showed 3 volts and the current showed 0. And the current was 0 since the circuit was then not complete and the voltmeter was only measuring potential difference, which was 3 volts. We then, looking at the diagram on the right, we took all those points and found the potential difference between each point and the subsequent point and got AB equals 3, BC equals 0, and so on. And using loop rule, we summed up each one and found that the round trip potential difference was 0 volts, as shown in the graph below. After putting in a parallel ammeter into the resistor that was 100 ohms, the current became 0.06 instead of 0.02. And putting a voltmeter did not change anything. And I believe that this is the case because it has a very high resistance, so it didn't change the ammeter. So using the potential difference values that I showed earlier that are shown on the left now, we were able to calculate the resistance for the 47 and the 100 resistors, the wire, and the ammeter by using Ohm's law, which is V equals IR. We can say V equals IR, and then that means R equals V over I, which gave us 48, 102, 0, and 0, respectively. For part 3, which was the RC circuit, when the batteries were connected directly to the bulb brightened and then dimmed. When the batteries were connected to a capacitor and then to the light bulb, it just brightened and dimmed. And same thing happened when the capacitor was discharging. When the battery was disconnected completely, it got bright, dimmed very slowly, but the capacitor did not recharge because there was no battery. Then we measured the time it took when the capacitor was charging and when it was discharging for both the 10 ohm and the 20 ohm light bulb, and found that the charge and discharge times were approximately the same for both. So then the part that had to do with time-dependent voltage across a discharging capacitor in RC circuits, we used the formulas above and the simulation circuit on the left, and in order to create an ln delta V over delta V naught versus time plot, where 1 over the slope of that graph would be our value, experimental value for RC. This was the Excel file that was used to create the graph, and as you can see, the slope is negative 0.1667. For the calculations, the slope of the line was determined, and from that, we rearranged the equation such that negative 1 over the slope gave us 6 seconds for RC. And from the Excel trend line calculations, RC was 6 seconds, and from the simulation, 30 ohms times 0.2 farads is also 6 seconds. So the percent error between the simulation and the experimental value was 0. Some sources of error were that the time and corresponding voltage calculations may not have been perfect, and this can be shown by our R squared value for the line which showed 0.99999, which was not perfectly 1. For the what if questions, a real emitter would have a non-zero resistance, which means they're not ideal and impact the overall circuit resistance, and this would impact the results of the lab. Similarly, for the second what if, without a resistor, the charge is immediate, and in real life, however, there would be a wire resistance that results in a non-immediate charge of the capacitor. Thank you.